hear me?
Yes, it's fine. We can get started.
Okay. So welcome to our evening lesson. And this is chemistry. In case you are around and you don't know which subject it is chemistry. And our topic is, we are looking at chlorine and its compounds. So before we start, I want to request one of you to give us an opening prayer so that we can have God amidst ourselves as we go through this journey of academics. So I'm going to choose at random. Someone take us through a prayer, a short one. So, and those ones are without the names, please put your name. Galaxy J4 Core, that is not your name. Unless if you are a robot and you're Android. So may I request Sarah? Sarah, please take us through a prayer. Sarah?
Yes, teacher.
Take us through a prayer.
Okay. Let's close our eyes and pray. Lord, thank you for the gift of life you have given to us. It's by your mercy that we are still alive. Thank you for the gift that you have given us, that we are still learning online. Lord, help us that whatever we learn may get stuck into our heads, and so that we may excel in life. I've prayed this through Jesus Christ our Lord. Amen.
Thank you so much, Sarah. So once again, this is chemistry senior 3. In case if you are here and you are in senior 2, senior 1, I'm sorry to tell you that you are in the wrong class. Okay. So we shall basically continue from where we stopped last time. That was in the first lesson. Those who happen to be with us, who are with us from the beginning, you are aware where we stopped from. And it is very unfortunate that the assignment I sent in to your Google Classroom, most of you didn't attempt. And those who attempted, thank you so much. Others you didn't. I don't know whether it was intentional or I don't know exactly what that means. So I'm here to encourage you that next time when the work is posted, when the assignment is posted, let us try to do the assignment so that we can know how far we have gone or how much we understand. So the next time I post an assignment, let's try to do the assignment. And even the notes. I don't know how many access the notes and maybe copy the notes. That one I'm not sure. But as we move on, I'll get to understand those who didn't and those who did. Yes, you are saying that you're sorry, but I think that is the only option as per now to be sorry. But remember, whenever we give excuses towards our success. At the end of the day, when things go bad, we shall blame the teacher, especially. That is in academics, when you don't perform the way you're supposed to perform, then always the blame goes to the teacher. But we can avoid that. Olivia, what do you have to say?
Good evening, sir.
Good evening to you.
So I'm requesting you to please, can you please pardon? Okay, can you briefly review what you taught last time? Because me, it's my first time to join this lesson.
Okay. Thank you. Yeah, I will, but it can't be the same as when I'm teaching. I always become, very fast so that we can have enough time for the new things. But you can use the Google Classroom. We can interact from there. Then you can get to know what you didn't understand. So basically, we looked at chlorine and its compounds, and that is our screen. So we looked at, that was our topic for those who are not around. So we looked at chlorine, how we can identify it or locate it on the periodic table. We see it is in group 7. And from there, it has also other members, which include fluorine, bromine, and iodine. And a group where we find chlorine, it is called the halogens group. The collective name for group 7 elements, we call it halogens. Then we looked at the meaning of the word halogen. We said this means salt producers. Then we looked at the preparation of chlorine, whereby we say that we can have a general method for preparation of chlorine, and that is oxidation of hydrochloric acid, whereby in this case, hydrochloric acid has to be concentrated. And then from there, we looked at what can we use. Apart from using concentrated hydrochloric acid, we need what we call an oxidizing agent, which is going to bring about the oxidation. And we had examples which included potassium permanganate, or what we can call potassium manganate 7. We also had manganese 4 oxide. We also had lead 4 oxide and tritetra oxide. Then some people call lead 4 oxide, some call it lead dioxide. So in case you hear about lead dioxide, that is the same as lead 4 oxide. Then amongst the 4, we say that we have the ones which are common, which include potassium permanganate and also manganese 4 oxide. So these are the 2 oxidizing agents which are commonly used. Though they are 4, but we have those ones which are commonly used. Then from there, we looked at the preparation of chlorine from hydrochloric acid by oxidation with manganese 4 oxide. So here we chose to use one of the oxidizing agents. And again, I said the hydrochloric acid must be concentrated. Then we looked at the procedure or the steps that we follow. We place some manganese 4 oxide into a flask, and then we prefer to use lumps. Lumps, when I talk of lumps, I say those are big particles. So we prefer to use the big particles rather than using the powder, because the powder is very reactive. And then we have the apparatus, as we shall see the way it is arranged. Then we say that we pour concentrated hydrochloric acid down the cysto funnel. So you can choose to use a cysto funnel, or you can use a dropping funnel, or you can use a tap funnel. Then after that, we heat the mixture. That is after when concentrated hydrochloric acid has reacted with manganese 4 oxide, then we heat the mixture. Then from there, that is the diagram. This is the diagram whereby here we are having concentrated hydrochloric acid. Then here we have a mixture of concentrated hydrochloric acid and manganese 4 oxide. And then we have water, where we say that chlorine is produced together with hydrogen chloride gas. And we are getting hydrogen chloride gas because of using concentrated hydrochloric acid. If it was dilute, it doesn't do that. Then we pass the gas through water so that we can remove hydrogen chloride. Then from there, we pass chlorine gas through a drying agent, which is concentrated sulfuric acid. Then therefore, after that, the gas is collected by downward delivery. And we give a reason as to why the gas is collected by that method, I will say it is because the gas chlorine is denser than air. So we conclude from there. We looked at observation. Observation is exactly what happens in the flask when the hydrochloric acid meets the manganese 4 oxide. So the moment they meet or they react, we shall form a greenish yellow gas, which is chlorine. But remember, we say that chlorine is formed together with small amount of hydrogen chloride, which are mixed fumes. Once again, I say that we get hydrogen chloride from concentrated hydrochloric acid. And then we can remove such traces of hydrogen chloride by passing it through water, whereby this gas here would dissolve in water. Then the gas dried using concentrated sulfuric acid. And we said also it can be collected by downward delivery, since you can use the word since, or you can say because it is denser than air. So basically here we said it is just explaining what happens in the diagram. Then we can have the equation of what took place in the flask. And that is the equation where we have manganese oxide reacting with hydrochloric acid. Remember, I said the acid must be concentrated. So if they ask you the conditions for this reaction, there are two. There must be heating, and also the acid must be concentrated. Then chlorine, we said, is poisonous, so it is prepared in the fume chamber. So the fume chamber protects the person preparing the gas from inhaling it or breathing in the gas. And since we are saying it is poisonous, it means that it can easily kill a human being in this case. Let me first look at your questions. Someone is saying that, guys, we are learning. Thank you for that. Yeah, my voice is low, but at times it is because of the network. At times it can be my network or it can be yours. Okay. Someone is asking how to submitting the assignment in the Google Classroom. I will post you a video, the one you watch and get to know. Yes, I'm okay.
Excuse me, sir.
Yes, please.
I'm kindly requesting you to repeat for me the equation.
Okay, you want to write it?
Yeah, I want to write it.
Don't worry about that. I will post the note. The notes are already there in the Google Classroom.
No,
I'm just reviewing what we looked at in the first lesson. We haven't looked at the work of today's lesson.
No, sir, it's like I'm just doing this school. I'm from another school.
Okay, but still, what I said can still, I will send the notes, then you get the equation.
Okay, thank you, sir.
Welcome. Olivia?
Yes, sir.
Yes, please.
Sir, I have a question. Why is it that when in the preparation of hydrogen is dried using concentrated sulfuric acid, is it that because they can't react?
I beg your pardon?
Why is it that hydrogen is dried using concentrated sulfuric acid? Is it because that they can't react?
Exactly. For any drying agent to be used to dry a gas, those two must not react, because if they do, it means that we shall not have the gas. The gas will be produced, but at the same time it will be used in the reaction, to be used up during the reaction. So they shouldn't react at all. That's why in the future we shall find that ammonia cannot be dried by concentrated sulfuric acid, because those two react to form ammonium sulfate. Is it clear?
Yes, thank you, sir.
Welcome. Mariam, the next time you joke around, I think you'll be suspended from the class. The person asking how to join the Google Classroom, we shall let you know. We shall send you a video, and then you'll be able to know how to enter. Okay, thank you for those questions. Let's continue. So here we are going to use, instead of using potassium, rather, instead of using manganese oxide, let us use another oxidizing agent, which is potassium permanganate. Remember, we said that we have two common oxidizing agents. One we said is manganese oxide, the one we have looked at in the first experiment. Then secondly, potassium permanganate, or the one that we can call potassium manganate 7. Potassium manganate 7 can appear in both forms. It can be a solid or it can be a solution. Okay, so let's see what happens. The procedure is there. So here we are going to use solid potassium permanganate. I want us, as we look at the second procedure, the second experiment, we also keep on reminding ourselves of what happens in the first one, so that at the end of the day, we can compare the two and we make deductions of which one is the most favorite or the best of the two. And then we feed the apparatus as shown below. We shall look at the diagram, and that is our diagram. So we are having concentrated hydrochloric acid. It is added to potassium permanganate, which is in solid form. And then we shall produce chlorine gas. What we should know is that in this case, the gas we are preparing, the chlorine we are preparing is not dry, since we are not passing it through a drying agent. Then another thing, the gas chlorine here, it is not pure, given that whenever we are producing chlorine gas, it is always produced with traces or some small amount of hydrogen chloride. And to remove the hydrogen chloride gas, we pass it through water. But here we are not having any water. In other words, our gas is not all that pure. So we collect the gas over water, which is always with the brine. So that is the diagram. So that is the first procedure or the first step. Drop potassium permanganate into with the concentrated sulfuric acid from the funnel. And then as each drop, this second point, this second step is very important. We might need it in the near future. As each drop reaches the manganese, it is supposed to be potassium permanganate. It is supposed to be potassium permanganate. We can add it there. We can say here it is supposed to be potassium permanganate. So as each drop reaches the potassium permanganate, a corresponding quantity of chlorine, which is a greenish yellow gas, is evolved. So what does this mean? It means that since we are having potassium permanganate in a solid form, each particle of potassium permanganate counts, and each drop of concentrated hydrochloric acid also counts. Meaning that if one drop can produce, let's say 5 cubic centimeters of the gas, and I want, let's say 20, it means that I will only need 4 drops to give me the 20 cubic centimeters. So what we should know is that whenever we are using potassium permanganate as an oxidizing agent in the preparation of chlorine gas, the production of chlorine can easily be controlled. So we can easily control, or we can easily prepare what is enough for a given purpose. Unlike when you're using manganese oxide, whereby you can produce either less or you can produce either too much. So we should know that when we reach comparing the two oxidizing agents, that is manganese oxide and potassium permanganate, we should know that potassium permanganate is better than manganese oxide because of that one reason. It is one of the reasons that's why we prefer potassium permanganate to manganese oxide. Then from there we continue. So I hope you have quoted that, so we can remove that. Then that's the equation. That is the equation where we are having, this is potassium permanganate reacting with concentrated hydrochloric acid. Then we form potassium chloride, we form water, manganese 2 chloride, and the chlorine gas, the one we are interested in. And during your free time, you can try out how to balance this equation, not depending on what is already on the screen. Someone is asking whether potassium permanganate is the same as potassium manganate. According to what you have written, it is wrong. It is not the same, unless if you say that potassium permanganate is the same as potassium manganate 7. So you must put 7 in the bracket. So it is supposed to be potassium manganate 7. It's supposed to be like that. The way I've sent it in the chat, you can check it out. Check the spelling potassium, but that 7 is supposed to be there. Yes, MK.
Excuse me, sir.
Yes, please.
Do we have the catalyst in this reaction?
And no, not yet. We don't have the catalyst.
Okay.
Yeah, that is also one of the reasons why potassium permanganate is a good oxidizing agent. It can act as its own catalyst. Okay. Someone has sent an emoji crying. I don't know what is wrong. Okay. So once again, I was saying that during your free time, you can try out balancing that long equation. Then from there, the gas can be collected by downward delivery over water, over brine of hot water in a gas syringe. The reason that's why we collect the gas over brine is to make it less poisonous. So when you're using potassium permanganate, you have a chance of collecting the gas over brine of hot water so that the gas becomes less poisonous. It is just becoming less poisonous, but remains poisonous. So once again, like I said, using potassium permanganate, it is the most convenient. It is the most convenient laboratory method because of the following reasons. Who can tell us one of them? I've already mentioned one of them. I've already mentioned one of the reasons why potassium permanganate is preferred. We can have JB. JB, it seems he was just stretching his hand. We can have sing with Anthony. Anthony.
It is less poisonous.
It is less poisonous. Okay, thank you for trying. We can have, I say that if you don't have the name on your device, if you didn't name your device, I will not pick you because someone with Galaxy S7, may you please put your name so that we can get to know each other. Let's have Procy.
It acts as its own catalyst.
It acts as its own catalyst. Thank you.
Yeah.
Another one. Thank you, Procy. Another one. Let me see. Some of you have had names. So you just need to keep looking at your screen and when I ask you to unmute. Kasim.
Yes.
Hey, yes.
Can you hear me?
Yeah, I'm hearing you.
Yes, the production of chlorine in this method is controlled.
Okay, thank you. Thank you so much, Kasim. That is point number one. Whatever we have said, all of them are correct, but we have the ones which are very strong points. So let's first mention the strong one. The strong one, the first one is the production of chlorine gas can be controlled. Anybody knows the second? Anybody? Let me see. This one. First, how do you pronounce your name?
It does
How do
not
you pronounce your name?
Yeboash.
Sorry?
Yeboash.
Yeboash, okay.
It does not explode when heavily heated.
It does not explode when heated. Okay, thank you for trying. Olivia?
Yes, sir.
Yes, please.
Pardon, sir.
We are asking, why do you think using potassium permanganate is the best or the most convenient method for laboratory preparation of chlorine?
It's not poisonous compared.
It's not poisonous compared to the others. Okay, thank you. Thank you for trying. Kasim, are you back? Okay. Kasim, I see your hand up and I'm requesting you to unmute.
Yes. The gas evolved can be collected over brine to make it less poisonous.
The gas collected can be collected over brine to make it less poisonous. Thank you so much. So we are only remaining with one because we have three most important reasons. So far we have the gas production can be regulated or controlled. And secondly, we can collect the gas over brine, which makes it less poisonous. Anybody who can give us a third one? Anybody who can give us a third one? Okay, naturally. Let's have Marcel. Marcel? Sarah has just disappeared. So Olivia?
Yes, sir. It does not require a catalyst.
It does not require a catalyst. Thank you. Okay, thank you all for your answers. Let's look at what I have. One, it does not require heating. If you are to check on the setup, for the case of when we used manganese oxide, you can see that we had some heating here. We applied heating. But then when we look at manganese oxide, there is no heating. So whenever we are using potassium permanganate, there is no heating. So we are here. It does not require heating. That is number one. Let's check in the chat. Someone said that it's a catalyst, strong oxidizing agent. Thank you. Someone is saying, hello, guys. And then someone said that is a Prisca said it gives a desired quantity. I think that is almost the same as saying it gives a controlled amount. Okay, let's look at a second. We also say the rate of production of chlorine can be regulated, which is the same as controlled. Then thirdly, if the gas is collected over brine, the experiment can be done out of the fume chamber. What does that mean? It means that the chlorine being produced is less poisonous. So that's why it can be done out of the fume chamber. So apart from the methods we have looked at above, let's look at other methods we can employ to prepare chlorine gas. Yes, Priska?
Teacher, I was told like every method prepared using a round bottom flask involves heating.
Involves heating? Yes, most of them, but not all of them. Normally we use a round, like you said, when you're going to heat. Because when you have a round bottom flask, it can't rest on a flat surface. You must hold it with a clamp. And like you said, we always use those ones whenever we are going to heat. But for the case when you go to heat, it means that you can put the flask on maybe a table or a flat surface. And if you are to check on a diagram of potassium permanganate, we are using a flat bottomed flask. Then with manganese oxide, we are using a round flask, a round bottomed flask. Philman?
Yes, please, teacher.
Yes, please.
Teacher, what is a brine?
A brine is the same as concentrated sodium chloride.
Thank you, teacher.
Welcome. Then MK.
Excuse me, sir.
Yes, please.
About this point, at the third point, if the gas is collected over brine, the experiment can be that point. Chair, I've not understood it properly.
Okay, thank you. I'm going to get back to you. Let's hear the last question. Kasim?
Yes. Can the gas evolved in this method be passed through a drying agent to be collected dry?
Yes, it can be. It can be dried.
Yes.
So maybe to answer Kasim and MK, if you are required to prepare a gas when it is dry, when you are using potassium permanganate, instead of collecting it over water, instead of collecting it over water, you don't. So from here, you pass through a drying agent. Whenever it is produced from here, then you pass through a drying agent. So from here, we put another wash bottle, maybe containing a drying agent, like the way we have it here. So we can do this from here, then we pass through also water because it's the same acid we are using. Then the gas can be collected over water. Then someone asked that how can the gas be collected over brine be made less poisonous? So the brine, the sodium chloride, reduces the concentration of the chlorine gas. The poisonous nature of chlorine gas is reduced by the brine, the one we called concentrated sodium chloride. It's just reducing the poisonous nature, not necessarily making it poisonous free. It is brine. The word is brine. The first one. Banja. It is brine. B-R-I-N-E. Someone is asking that examples of drying agents. We have calcium oxide. We have concentrated sulfuric acid. We have anhydrous calcium chloride. Those are the ones which are common. Then someone is asking if anyone is from Ebenezer. I don't know. Okay, so the last point I said that I said that this one is just the brine makes the gas less poisonous. And that's why we are able to collect it out of the fume chamber. The use of the fume chamber is protect the person preparing the gas from inhaling it or from breathing in that gas. It is always the fume chamber is always made of glass, whereby you just put the hands inside through 2 holes, you wear your gas mask, then you prepare whatever you want to prepare from the fume chamber from inside. So you don't put that your head, you just see through the gas. Someone is asking whether we can prepare it from sodium hydroxide. Yes, we shall see it. We shall see when we reach there. We shall see when we can have sodium hydroxide in the preparation of chlorine gas. Okay, so let's look at other methods for preparing chlorine. So we can prepare chlorine from sodium chloride. We can prepare chlorine from sodium chloride by adding their concentrated sulfuric acid in the presence of manganese oxide. We can use sodium chloride by adding concentrated sulfuric acid in the presence of manganese oxide. So from there still, since we shall produce some traces of hydrogen chloride, which are removed by bypassing the gas over water. Where does this hydrogen chloride gas come from? Given that we don't have concentrated hydrochloric acid. So whenever you get solid sodium chloride, whenever you get this one, sodium chloride, which is in yellow, then you react it with concentrated sulfuric acid. Whenever these two react, they will give us hydrogen chloride gas, which is HCl. And we shall also use the same reaction or the same reagents whenever we are preparing hydrogen chloride gas. So these two react together to give us hydrogen chloride gas, which is then oxidized by manganese oxide. So that is how the hydrogen chloride gas comes in. Once again, hydrogen chloride gas comes in because of the reaction of sodium chloride and concentrated sulfuric acid. So it is this gas that is again oxidized by manganese oxide. Then part of it will be oxidized to chlorine gas. Then another part will remain unchanged. What do I mean? It will remain as hydrogen chloride. So the one which remains unchanged, it is the one that we remove by passing over water. I hope that one is clear. Yes, Bena is saying that can it be prepared by sodium from sodium chloride? Yes, that is what we are looking at. So after removing those ones, then we can collect the gas by downward delivery method after drying it. After drying it, and that is our equation. So we are having sodium chloride reacting in the presence of manganese oxide, reacting with concentrated sulfuric acid. Then we form sodium sulfate, manganese 2 sulfate, water, and chlorine. So before we proceed, any question on that? Any question on this method? The one we just finished. The one where we use sodium chloride, manganese oxide, and concentrated sulfuric acid. If you have any question on that, you can raise up your hands. And we need to be fast. Yes, Olivia?
Yes, sir.
Yes, please.
Sir, is chlorine a bleaching agent that it can change the blue litmus paper red and then from red to blue?
From red to white, not blue?
Yes.
Yeah, chlorine is a bleaching agent, but it only does that when it is dissolved in water. As long as it is dissolved in water, that's when it can act as a bleaching agent. But when it is dry, does not bleach. We shall look at that when we reach there. That is where we are heading to. But when it is dry, it does not bleach unless if it is dissolved in water. As long as there is some content of water, then it would bleach. There is some small chemistry behind that. We shall look at the details. Thank you. Then Arafat.
Yes. Is heating a condition in this method?
Heating, I beg your pardon?
Do we heat in this method the solution?
Yeah, we can heat or we might not heat. Heating can be applied at times. The use of the heating is to speed up the reaction. So you may heat or you may not. Aisha. Aisha, unmute.
I would like to ask that apart from chlorine, which other chemicals can bleach litmus papers?
Okay, so far we can have sulfur dioxide can also do that. Sulfur dioxide that is covered under sulfur and its compounds. Sulfur dioxide can also do it. We have philomena. Sorry, the other time I was reading it as pheromone. Philomena.
You were saying that sodium chloride prevents choking when you're preparing it in the other method of using potassium permanganate. Yeah. So now when you're using this method, does it still prevent choking, and do you still have to prepare it in the chambers as you said?
Okay, thank you. So in this case, if you are prepare chlorine, for example, you need a compound that contains chlorine. And you need a compound which can easily be oxidized. If we are to look at the first slide, we are having oxidation of hydrochloric acid. And remember, we can define oxidation in 3 ways. we can define it as addition of oxygen, or we can say removal of hydrogen, or loss of electrons. So since we are having hydrochloric acid, which is written as HCl, and we are saying that it is oxidized to form chlorine, it means that this hydrogen is the one which is removed. That is how the oxidation comes in. So when we come back to this other method, when we come back to this one, we are having sodium chloride and concentrated sulfuric acid to make sure that we produce hydrogen chloride, which is easily oxidized by manganese for oxide. So the use of sodium chloride in this case, it is to react with concentrated sulfuric acid to produce hydrogen chloride, which is easily oxidized by manganese for oxide. And again, here we are using solid sodium chloride, not concentrated sodium chloride. So this is not brine. This one can be like a table salt. It's not concentrated, it is in solid form, but this one is concentrated. I hope I've made it clear.
Yes, teacher, thank you.
Welcome. So you can unmute yourself. What are products? Patricia is asking, what products are formed when chlorine reacts with sodium? Maybe you meant reacts with sodium. We form sodium chloride. We form only one product, which is sodium chloride. Why do we put manganese oxide? Like I said, we are putting manganese oxide to oxidize the hydrogen chloride, which is formed, so that we can get chlorine. I hope I've answered your question, Patricia. Sorry. This is Nakawoya. I hope I've answered your question. All right. So we continue. So we are saying that the gas is dried using a drying agent. Here we are using concentrated sulfuric acid, or you can use anhydrous calcium chloride, which is always in solid form, and there we put it in a U tube. And we said the gas is collected by downward delivery method because it is denser than air, or we can say it is heavier than air. And that is the equation. Other methods, still the second one, chlorine can also be prepared from a bleaching powder, and the bleaching powder is calcium hypochlorite. Another name for bleaching powder is calcium hypochlorite. So this is what happens. The bleaching powder is placed in a flask, and dilute acid, and the dilute acid is added. So here we can choose to use dilute nitric acid or dilute hydrochloric acid. So we should know that whenever we are having a bleaching powder or calcium hypochlorite, we don't use a concentrated acid. We use a dilute acid, and we are given two options. We can either use dilute nitric acid, or we can use dilute hydrochloric acid, then we add it to the powder, which is the bleaching powder. Then is chlorine also part of air? No, it is not. Chlorine is not part of air. It is not found in free states. So lastly, the last part, then we shall have effervescence of our greenish yellow gas, that is chlorine, and then the gas can be dried, collected by any methods we discussed. Can be over water, or it can be over, we can use a downward delivery, then the equation. The first equation is when we have nitric acid, then the second is when we have hydrochloric acid. So when we meet next time, we shall look at the industrial manufacture of chlorine. That will be in the next lesson. And from here, I'm going to post the notes and also an exercise, but I'm going to post an exercise not until you first attempt the first one. Those who haven't, please make sure you attempt the exercise. Those who don't know how to submit in the work, we shall share a video whereby you'll be able to know how to submit in the work. So we can meet from the classroom. You can post your questions there, then I'll be able to attend to you. We are remaining with only 2 minutes. I will entertain only one question. Only one question. Here we have Rashford, Samson Rashford of Uganda. Samson?
Mister,
Yes, please.
can you please send me the Google link of the classroom?
Okay, you get it. Bernard, I request that you share the Google link. Then let's have someone to give us a closing prayer. Patricia, welcome. Let's have this person. There is person called Blessing. 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 Barbara Blessing, you can bless us.
Okay, let's pray. Dear Lord Jesus, we thank you for this lesson. Thank you for every single thing that we've learned from our teacher, the reporters, and also bless him with more knowledge that he may teach us.
Have we finished? I think amen, because we've not been hearing well. So lastly, those who are asking for the links, they are there. Check for them very fast before we go off. You write down those links so that you can join later. There's one for the Google Classroom, then for the videos to see how you can log in, how you can submit the work, and how to find how to look for the work from the Google Classroom. So I thank you all for attending the lesson, and I wish you a good evening. Kakuru, thank you for being part of us.